Welcome to the internship program. I am Shubham Gupta from NextGen AI Frameworks Pvt Limited. I have 14 years of work experience in the fields of artificial intelligence, software development and robotics. This is part 3 for digit classification project. Let's continue. Now comes the part of creating the thing or model. So let's see, as I told you, you will be working in layers in this Keras or TensorFlow. You will be working in layers. So this is how you can pass the layers in this list. As you can see, you can pass the layers like this. So what this is I will tell you step by step. So what flatten layer means? What flatten layer means? Convert 2D images into 1D vectors. As you know, these are 2D images, two-dimensional images. So X and Y, you can see these are two-dimensional images. So for the computation to convert it to 1D vector, you can use flatten layer. I will tell you step by step how it is done. Then the dense layers, fully connected layers with activation functions. So let's see step by step. This is first one is input layer. Second one is hidden layer. Third one is output layer. So if you see here keras.sequential, so we are using keras. So defines a neural network model using TensorFlow keras API. This model consists of 3 layers: input, hidden, output. Then comes, you will see these activation functions. What it means or what they do is, let's see. In simple words, ReLU, rectified linear unit, is an activation function used in neural network that works as follows. If the input value is positive, ReLU keeps it the same. If the input value is negative, ReLU changes it to 0. So what this activation function will do is, if the input value is positive, it keeps it the same. If the input value is negative, it changes it to 0. This is very simple example how this function works. If you want to go deep into it, it is up to you. Just the basic, this is how it works, and this is how you call the activation function, like this. Now comes the part, if the input is 5, ReLU outputs 5. Because it is positive, it will not touch it. But if the input is -3, it will output 0 since it is negative. This is what this activation function will do. This is very basic, but things are complex in the background. This is just the example how it works. So again comes the question, why should I use it? It is simple to use, easy to compute, non-linearity. It helps the neural network learn more complex patterns by introducing non-linearity, speeds up training and often leads to better performance compared to older activation function like sigmod or THN. So what is happening is, just remember these words: speed up training, easy to compute. Speeds up training, easy to compute. Just remember these keywords so that you can use these things in projects. And in essence, ReLU helps the neural network focus on the important positive signals and ignore negative signals, making the training process more effective. This is what it will do. Okay, so I have mentioned here this also. Sequential mode in Keras allows you to build a neural network by stacking layers in linear order. So this is linear order, one by one, one by one. Each layer has one input and one output, making the model simple and intuitive. So one input, so here comes the input, goes the output, becomes the input for next layer, goes the output, becomes the input, comes the output. So this is what it is talking about, sequential. Now what flatten means, this layer converts a 2D input, this layer converts a 2D input. So what we have here is 28 by 28 pixel size images convert to 1D vector. Okay, so finally let's see what will happen. Each 28 by 28 image which is 2D is transformed into 1D vector. So what will happen, 28 multiplied by 28 is 784. So 1D vector will be of size 784. This is what will happen from from 2D to 1D vector. This is what will happen, 784 new 1D vector will be created. So why again comes why? This is necessary because fully connected layers expect 1D vectors as input. So they read 1D vector and not the 2D data that you are giving. It reads 1D vector. So this is the reason you have to convert it to 1D vector. How to do this? Just one line of code. This dot flatten, input shape is this, and it will convert it to a 1D vector. Layers.dense, what it means is this layer is a standard fully connected neural network layer. So where is the dense layer? This is the hidden layer, dense layer with the ReLU activation function. So what it contains is layer contains 128 neurons. Each, again read this carefully, each neuron takes the 784 input values from the previous layer after flattening and learns to extract feature from them. Again I will show you, if you remember the example or what I gave, each one is connected with the next one. So what this line is saying is coming from the previous layer. So let's see, each neuron takes the 784 input values from the previous layer. So in first layer what we did was flattening. What we get, 1D vector of 784 input values, and they are connected with the next layer and learns what will happen is, and it learns to extract the feature from them. This is what will happen with 128 neurons or unit. This is what will happen, it will take the data from the previous layer and compute it in the simple words. And I already told you about activation function, ReLU, rectified linear unit. I already told you what this is. So this is how you call the activation function and simplify the things. Why? Again remember, fast, quick, for all those things you have to use activation function, and there are many activation functions available. For this project I am using this. There maybe some other can also be used, but for this one I am using this. Now the layer.dense, if you look at this one, what it means is, 10 neurons. There are 10 neurons corresponding to the 10 possible digit classes. Why 10 neurons? correspond to the 10 possible digit classes. So why in this layer we are doing this? Because you know we will need the output in the form of digits. As you can see, we will need the output in the form of digits. So 10 neurons in the MNIST dataset, or each neuron represents the probability of the input image belonging to one of these 10 classes. I told you output will be from 0 to 9 only. So this is the thing. Now the activation function used is softmax. So softmax is used as the activation function. Softmax converts the raw output scores of the neurons into probabilities which sum to 1. The class with the highest probability is the predicted label. So how the output will come is the best match. The best match will be the predicted label. I told you in previous sessions what label means. It's just the output. You call in machine learning those things as label. Just for the conclusion of the model flow, I have written this. So just for the conclusion of the model flow, input, the model takes an input of size 28 by 28, which is a single grayscale image. Flattening, the image is flattened into 1D array of 784 elements. I already told you why 784. 28 multiplied by 28. Why? Because the layer understands the 1D vector array only. Hidden layer, the dense layer with 128 neurons learns to extract feature from the 1D input using the ReLU activation function. Output layer, final dense layer with 10 neurons, uses the softmax activation function to predict possibilities for each of the 10 possible digit classes 0 to 9. So this is the reason we gave their 10 neurons, because the output will be from 0 to 9. From 10 classes, 10 digit classes will be the output. And this one, dense layer learns 128 features from the input. So it will extract 128 features from the input, and this output probabilities for each of the 10 classes digits from 0 to 9. These are two dense layers, and first is flattened layer. So I will continue this session from point 5, compiling the model, in the tomorrow's session. If you have any doubt, you can ask. I will continue this session in next video. See you in next video. Have a nice day.